of nitric acid is low. So we have experienced a quite number of loss. And also the images from Kampung Harapan has sent us a report about the liver being polluted by our nitric acid. So I want you to collect information on how to increase our production of nitric acid and how to increase the quality of the liver. That's all.
Okay.
Hello. Yeah. Saya ada problem. So can we set up a meeting? Maybe just right now. So thank you all for responding to Taman Store and Taman today. So I would like to know what's your name and what your position.
I'm Artika. I'm the operational manager. I am Fatimata and I am environmental engineer.
And I'm Ahmad Shami, and I'm environmental specialist.
And I'm Khalid and I'm head of department chemistry in IIM.
So as you know, we are introducing nitric acid several steps, actually 4 steps. So what can we do with these 4 steps to increase the production of nitric acid?
I have an idea.
So, to produce nitric acid, as we already know, there are several steps. And for the primary oxidation step and formation of nitrogen oxide step, the step involves a reversible reaction, which is also an exothermic reaction. So, to increase the yield of production of nitric acid, we can change the temperature of the system. So, according to Lee-Titler principle, when the temperature is decreased from its optimum temperature, the reaction favors the exothermic reaction, which means the equilibrium position will shift to the right, while when we increase the temperature, the reaction favors the endothermic reaction, whereby the equilibrium position will shift to the left. So, from the equation, in order to maintain the exothermic reaction, which is forward reaction, we can decrease the temperature so that the concentration of product produced will increase. Hence, increase the yield production of nitric acid. Increasing in the concentration of product lead to increasing in K value. However, the reduce in temperature from its optimum temperature can lower the rate of reaction. Means even though we get the forward reaction occurs, the rate of reaction is low. So in order to overcome this problem, catalyst can be useful to increase the rate of reaction. Addition of catalyst will not change the equilibrium position. Besides, it allows reactions to proceed faster to a lower energy transition state.
I have an idea.
And one of the ways to increase the yield of nitric acid, we can change the pressure. For the step 1, which is the primary oxidation, this is the equation involved in the step 1. Okay, we need to decrease the pressure. And increase the volume in order to increase the yield of nitric acid. This is because, based on the Chatelier principle, if the pressure decreases by increasing the volume, the reaction will shift to the side which has higher number of mole gases. In here we have 9 mole, and here 10, which is the equilibrium position will shift to the right and will increase the yield of product in the step 1. So for the step 2, which is formation of nitrogen oxide, for this step we can increase the pressure and decrease the volume because due to Lee-Chatelier principle, the reaction will shift to the side which has lower number of mole gases, which is here we have 3 and here we have 2. And the equilibrium position will shift to the right and produce more nitrogen oxide that will be used in the third step. Okay, the third step is known as absorption of nitrogen dioxide and or also known as formation of nitric acid. Okay, for step 3, we need to increase the pressure and increase the volume. We can increase the pressure by adding more number of mole of reactant that will produce more product. And when pressure is increased, it will favor to site which has lower number of mole. Here we have 3 and here we have 1. So the yield of nitric acid can be improved.
Okay, so thank you. And I also have an idea of increasing the production of nitric acid. So increasing the production of nitric acid, we can also change the concentration. So this is one of the equations involved in the production of nitric acid. This is an equilibrium reaction, irreversible reaction. So as we know, the reaction can proceed as forward reaction or reverse reaction. But in this case, we want to produce the product so that we can produce more nitric acid. So to prevent the reaction from proceed to the left, so we can increase the concentration of the reactants, because according to the Lee gas principle, if we increase the concentration of the reactant, the equilibrium position will shift to the right, or in other words, it will proceed to a forward reaction, producing more product. So that was the first problem. The next problem is about the liquid. So I want to know how our production of nitric acid can affect the liquid. We know how.
Okay, as we know, natural rain is slightly acidic because of carbon dioxide combined with H2O produce carbonic acid. Acid rain is mainly from two gases, which is SO2 and N2. SO2 is produced from mining smelters and burning coals. Then it also produced from the mineral roasting, which is metal sulfide plus O2 will produce metal oxide and SO2 gas. Then SO2 gas also produced from electrical power station from the reaction of sulfur impurities that produce SO2. The SO2 gas then react with H2O produce sulfurous acid, and some of SO2 will further oxidize to SO3 because it catalyzed by water droplet and dust particles. Then it will produce SO3. Then the SO3 will combine with water, produce much stronger acid, which is H2SO4 sulfuric acid. Then the second substance that contribute to the formation of acid rain is N2. N2 is a diatomic molecules, and in a gas which it has triple bond. Then it will combine with O2, produce nitrogen oxide. This reaction requires high temperature, which is 1030 Celsius. The temperature is contributed by the internal combustion engine, which is human activity, and lightning in the atmosphere, which is natural. Then the NO, the nitrogen monoxide, slowly combine with O2, which will produce nitrogen dioxide, which is soluble in water. Then the nitrogen dioxide will combine H2O, produce two acid, nitric acid and nitrous acid. Then we have four acidic solution, which is sulfuric acid, sulfuric acid, nitrous acid, and nitric acid. Then it will combine in water, and then we produce strong acid rain.
Okay, thank you, Amma. So next, how to improve the quality of the liquid?
So there are two methods to improve the quality of food.
water, which is first lining, and second is CSS, which is carbon capture and storage. So for the first lining is the addition of limestone, which is calcium carbonate, CaCO3, to neutralize the acid waters and salt and buffer them from rapid fluctuations in pH. So this is the equation of neutralize the acid waters, which is the limestone, which is CaCO3, will react with nitric acid and produce calcium nitrate, carbon dioxide, and H2O. So by using lining, there are advantages, which is lining is cheap, easily available, natural mineral, easy to distribute and dissolve in water. So for the second step is carbon capture and storage, which is known as CCS. CCS is a technology that can capture up to 90% of the carbon dioxide emissions produced from the use of fossil fuels in electricity generation and industrial process. So by using CCS method, we can prevent CO2 from entering the atmosphere. There are three parts of CCS change, which is first capturing the carbon dioxide, second transport the carbon dioxide, and lastly third storing the carbon dioxide. For the first, capturing the carbon dioxide, capture technologies allows the separation of carbon dioxide from gases produced in electricity generation and industrial process by one of the three methods, which is pre-combustion capture, post-combustion capture, or oxy-fuel combustion. For the transporting of carbon dioxide is then transported by pipe, linear by ship for safe storage. So when storing the carbon dioxide is stored carefully in selected geological rock formation that are typically located several kilometers below the Earth's surface. So by using this method, which is CCS method, CO2 can be reduced from enter the atmosphere and can improve the quality of water.
Thank you. So with that, we have come to conclusion. All the problems have been solved. So that's all. Thank you everyone.
The pain and the pleasure all come together.